Can you see the screen? Can you see the screen? No. Okay, so I'm trying again.
Now we can see, Miss.
Okay, yes, now you can see. Applications of maxima and minima. We did these applications in our last class. Now today, we did a number of maths from this file, from this application of maxima and minima, and there were 2 maths remaining to be done today. 1 or 2. Yes, we did this. This was, I think this was the last one. A rectangular sheet of paper with perimeter 39 centimeter is rolled into a cylinder. What dimensions of the sheet would maximize the volume of the cylinder? I think this was the last one. So let us now go. Okay, I think this was also done. Am I right? Arch window consisting of a rectangle topped by a semicircle. Yes, this one also done. This one also done. Now there is one math remaining and it is done in a different way. So what is our question here? Find the dimensions of the right circular cylinder.
Miss, I don't think the charge window math was done. Miss.
Sorry?
Miss, I don't think the charge window math was discussed. Miss.
It was done. Charge window math was done. I'm sure. I'm sure it was done. You can go to the lecture file video of the lecture file. You can go through it. I'm sure. So this is the math today. Find the dimensions of the right circular cylinder of greatest surface area that can be inscribed in a sphere of radius r. So you have a sphere. You have a sphere whose radius is r. This is the center and the radius of the sphere is r. Just a minute. So here the figure shows that, okay, this is the circle with radius r and here the center is at O. And you have a rectangle, sorry, right circular cylinder, not a rectangle. And we have a right circular cylinder and we have to put this cylinder inside the circle. The cylinder should be inscribed within the sphere, okay, not circle, I'm sorry. It is a solid figure, right circular cylinder and a sphere. The sphere has the center at O and the radius is R. And the right circular cylinder should be inscribed within this sphere. Okay. When you put this cylinder within the sphere, definitely, if you join these two, it will be at here. One corner point to the other corner point. It will be a diameter of the sphere. BOD will be a diameter of the sphere. So the figure shows the enclosure of the right circular cylinder ABCD. ABCD within a sphere whose radius is R and the center is at O. Okay, now here BOD equal to 2R. BOD equal to 2R. Yes, because it must be the diameter of the sphere. So the radius, if the radius is R, so if BOD be the diameter, then it will be of length 2R, the diameter of the circle. Now, let us suppose that the radius of the base of the cylinder is small r. Let r be the radius, small r be the radius of the base of the cylinder, where definitely describe the cylinder inside the sphere. It is not possible. So smaller must be smaller than the capital R. So that BC equal to 2R. Yes, this side will be 2R. and this side is 2 into capital R. Suppose that the height of the cylinder be h. Okay, now you see this BCD must be a right triangle. BCD must be a right triangle, so BD will be the hypotenuse. So BC square plus CD square should be equal to BD square. BC square plus CD square should be equal to BD square. And what is BC? BC means 2R, so it will be 4R square. And CD means 8, so it should be 8 square. And BD means 2R, so whole square, it will be 4R square. So what is the value of 8? 8 becomes, 8 square will be 4R square minus 4 small r square. Take 4 common, so 4 into capital R square minus small r square. So this 8 should be equal to root over 2 into capital R square minus small r square. Here we have neglected the minus sign because the length of the height cannot be a negative number. Now, what is the total surface area of the cylinder? We discussed it in our last class in the math. The total surface area of the cylinder will be what? Sorry, the area of the curved surface. Surface area of the cylinder will be equal to the area of the curved surface, which is 2 pi r into h. How it comes? The perimeter of the base into the height. So 2 pi r h, and the area of the base is pi r square, area of the top is pi r square. So pi r square plus pi r square will be 2 pi r square, and then 2 pi r h. Yes. So if you take S as the surface area, it will be 2 pi r square plus 2 pi r h. And let us make it an expression into a single variable. So just put down the value of h. What was h? H was 2 into root over capital R square minus small r square. So now S, this surface area becomes a function of R only. Now, in our previous math, okay, in our previous math, we followed this way. We expressed this S in terms of a single variable, but you can follow another method. Here, we don't need to express this H in terms of R. Look into this. We solve this problem in a different way. SR, okay, not SR, here SR and H. 2 pi r square plus 2 pi r h. Here, we didn't put down the value of H in terms of R, okay. Take the derivative, find the derivative of this S with respect to R. Find the derivative of this S with respect to R. Remember that this H is a function of R. Just remember that H is a function of R, because you know the value of H is this 2 into root over capital R square minus small r square. Here capital R is constant because the radius of the sphere is constant. Radius of the sphere is constant, and this small r is a variable. And this small r, h is a function of this r. Just remember it. So here h contains a square root, so it becomes complicated. That's why here I didn't put the value of h. So just find the first order differential coefficient of this s with respect to r. So ddr of this whole thing. So separate the terms. 2 pi, this 2 pi is a constant, so ddr of r square, and here again 2 pi is a constant, so ddr of r into h. Remember, h is a function of r, so it is the product of two functions, one is r and the other is h. So here comes what? ddr of r square means 2r, and 2r into 2 pi, it gives you 4 pi r. And here 2 pi into, this is a product of two functions, so h into ddr of r, first function into the derivative of the second function, plus second function into derivative of the first function. So h into ddr of r plus r into ddr of h. So it will be like this, ddr of r and ddr of h. So here ddr of r is 1, so it will be just 2 pi h. And here, just keep it like this, r into dh by dr into 2 pi. Yes, dh by dr into 2 pi. Now, since we know this condition that 4r square plus h square equal to 4 into r square, we got it earlier from the right triangle. Using the property of the right triangle, we have got this relation. Now, we will use this relation, not these terms, this one. this one. So here again we differentiate this on both sides. So ddr of 4r square plus h square equal to ddr of 4r square. Now remember, this capital R is a constant. So this 4 into capital R square is a constant. So ddr of a constant will be equal to 0. So the right side is 0. And what is happening here? Again, you differentiate the two terms separately. For 4r square, from r square you are getting 2r, so it will be 8r. And here ddr of h square, what it will be? At first you have to differentiate this h square with respect to h. So it will be 2h, and it should be multiplied by dh by dr. It comes from the chain rule, because here h is not expressed as a function of r. It is h square, but remember h is a function of r. So you have to differentiate this h square, just taking this h as r. If it is an r, then the derivative of r square will be 2r, but here it is h, so it should be 2h into, you have to differentiate this h, because this h was considered as r. So 2h into dh by dr equal to 0. So what is the value of dh by dr? It will be minus 8r divided by 2h. Minus 8r divided by 2h. So ultimately it will be minus 4r by h. So this is the value of this differential coefficient of h with respect to r. Now you just put the value of this here in equation number 1. So you see that things becomes very easy. So it will be, in the left side, it was the derivative s prime r equal to 4 pi r plus 2 pi h plus 2 pi r into minus 4r by h. So here it will be what? These two terms remain same, and here minus 4r into r, so it will be 4r square by 8 into 2. Now we discuss the points where this derivative becomes 0 or infinite. So for a maximum or a minimum of the surface area S, the derivative of S, that means S prime equal to S prime R, either it should be 0 or S prime R does not exist. Here S prime will be equal to 0 when this whole thing equal to 0. And I think this sign should be equal to, not implied. It should be equal to. And you see, this is a polynomial function in R, so there is no point, no value of R where this derivative becomes infinite. So we have only one condition, S prime R equal to 0. Here S prime R does not exist. Okay. Here S prime S does not exist only when h equal to 0, and here h is the height of the cylinder, so h cannot be equal to 0. So this condition is not valid here. We have to take only the condition S prime R equal to 0, for which this whole thing should be equal to 0. This whole thing should be equal to 0. So what we get from this condition, you can divide throughout the equation by 2 pi. So it will be 2r plus h minus 4r square by 8. So it will be h square, yes, multiplied by h to both sides, h square plus 2rh equal to 4r square, right? So let us transform this relation into a perfect square in the left side. So to get a perfect square in the left side, you have to add what? R square on both sides. So h square plus 2rh plus r square. That means we are adding this r square on both sides. So this becomes a perfect square, h plus r whole square. And in the right side, 4r square plus r square becomes 5r square. So on both the sides, we have whole square. So h plus r should be equal to plus minus root over 5r square. That means root 5r. Yes, root 5r. So h will be equal to plus minus root 5r minus r. So the value of h will be, take r common, it will be plus minus root over 5 minus 1. Now if you consider, if you take the minus sign, the value of h becomes negative. So it cannot be, that's why we have to consider only the plus sign. And root over 5 is greater than 1, so it is okay. So you have to take only the positive sign. H cannot be equal to negative. So the only value of h is this, root over 5 minus 1 into r, And now you put down the value of h in this relation, and here you are getting the value of r, small r. So small r, you do this algebra, small r square into, it becomes 10 minus 2 into root 5 equal to 4r square. You can take 2 common and then divide by 2 to both sides. So r square into 5 minus root 5 equal to 2r square. So r will be 2r square. R will be equal to 2 plus minus 2 into capital R divided by 5 minus root 5. Now small r cannot be negative, so only we are taking only the positive sign. And here, um, here smaller equal to this, smaller equal to this. So if you put the value of r in the relation for 8, what was 8? Yes, 8 equals to root over 5 minus 1 into r. So now you just put down, because your 8 and r, 8 and small r should be expressed in terms of this capital R, because in this case we know only the value of this capital R. So in the relation for h equal to root 5 minus 1 into small r, now put down the value of r here, smaller. So it is root over 5 minus 1 divided by 2 into, here you take root 5 common, so it will be root 5 minus 1. So root 5 minus 1, root 5 minus 1 cancel. So there remains only 2 by root over 5 into r. Yes. So the value of h will be 2 by root over 5 into capital R, and small r equals to 2 by 5 minus root 5 into capital R. So these are the dimensions. The radius of the base of the cylinder should be 2 by 5 minus root over 5 into capital R, and the height should be root 2 by root over 5 into capital R. So these are the dimensions which gives the dimensions of the cylinder for the maximum surface area. So you see, this was the last math, and here this math is done in a different way. It is done in a different way, you see, totally different. And you can follow this method in the previous problems also, because the calculations are very easy here. The calculations are very easy here. Here you don't need to express the function in terms of a single variable. In that case, you have to find the derivative of the surface area or volume, whatever it may be, and there will be a relation which connects the two variables. So you have to differentiate the function and the relation on both sides and find the value of the derivative, particular derivative that you need in your particular math. So this is the end of our application of maxima and minima. Okay. Let us now go to a different topic, which is also a part of maxima minima, which is also a part of maxima minima. Okay. So now I am taking another one. Just a minute.
Miss, you didn't upload the other file.
Hmm. Just a minute. I'm sorry.
Miss, is there any chance you
Yes. Any chance of what?
Miss, is there any chance you could upload the lecture materials before the class? And that would be very helpful, Miss. And maybe just the night before.
Miss, are you there? Miss, if you're there, you're muted.
Ma'am, we can't hear you. Maybe you're muted.
Can you hear me now?
Yes, miss, if you can.
Yes, ma'am.
Actually, I lost the connection. I lost the connection. So let us now start again. So can you see the screen now?
Yes, ma'am.
Absolute
Yes, ma'am.
maximum and minimum. So this is another topic, but it is a particular topic of maximum and minimum. Absolute maximum and minimum. So what is the definition here? Absolute maximum and minimum. So this is the definition. Consider an interval in the domain of a function fx and a point x not in that interval. So it is not a small interval. It is a it is actually you are taking a big interval from the domain. Domain means the range on which the function is defined. Okay, on which the function is defined, and you are considering a big interval which contains this particular point x naught. A closed interval, of course. A function fx defined in the interval a to b. You see, this is closed. Third bracket means it is closed. Closed means x can be exactly equal to a, it will be the lower limit, and x can be exactly equal to b, this will be the upper limit. But if it is enclosed with first bracket, it means it is an open interval, and in that case x cannot be exactly equal to a. X should be greater than a and x should be less than b if it is open. Open means it should be enclosed with first bracket. But here it is enclosed with third bracket. That means the lower limit a and the upper limit b are included in the interval. Okay, so a function fx defined in this interval is said to have an absolute maximum at the point x naught, where x naught lies in this interval, in between a and b, if the value of the function when x equal to x naught is greater than or equal to fx for all x in that interval. So this value should be the maximum. F of x naught should be the maximum value for all x in this interval. Similarly, the function is said to have an absolute minimum at x naught if f of x naught is less than equal to fx for all x in that interval ab. So this is the definition. And if a function has an absolute maximum or absolute minimum, we say that the function has an absolute extremum or extrema. We got this term earlier. Okay, there are two theorems. If fx is a continuous function on a finite closed interval. Okay, if in this interval, the interval that you are taking, if in this interval the function is a continuous function, then fx has both an absolute maximum and an absolute minimum on that interval. So it is very clear. If the function is continuous function, if there is no discontinuity in this interval for the function, then this function must have an absolute minimum and an absolute maximum in this interval. Now the second theorem, if fx has an absolute extremum on an open interval AB. Open interval AB means the lower bound and the upper bound is not included in the interval, then it must occur at a critical point of fx. This is important. So if the endpoints are not included in the interval, then the absolute maximum or absolute minimum must occur at a critical point of the function. Okay. Now there is a procedure, clear procedure, the steppings are there to how to get the absolute maximum or minimum for a function. So this is the procedure, step-by-step procedure to get the absolute maximum or minimum if there is any for a function in a given interval. Procedure for finding the absolute, okay. So what is the step 1? Find the critical points of the function in the open interval AB. Okay, in the open interval AB. So the critical point must be greater than A or less than B, because you have to consider the critical point in this open interval. Then you evaluate the function at the critical points and at the endpoints A and B. Evaluate fx at all critical points and at the endpoints of the closed interval. Okay, your interval is given as a closed interval, but when you find the critical points, you cannot consider the endpoints A and B. But when you find the value of the function, you have to find the value of the function at all critical points and at the endpoints of this closed interval. That means find the value of the function at x equal to A, at x equal to B, and at all critical points. Okay, the largest of the value in step 2 will give you the absolute maximum value of fx on this interval, and the smallest value in this step 2 will give you the absolute minimum value of this fx. So this is your working procedure. This is your working procedure if your interval is this. A, closed interval A and B, where A and B both are finite. But if this A and B are infinite, then the procedure will be a little different. Here
Miss,
we
what
have some,
fx is discontinuous?
sorry,
If fx is discontinuous,
if fx is discontinuous, in that case, there may not be any absolute minimum or absolute maximum, any one of the two. Either there will be no absolute maximum or there will be no absolute minimum. It depends on the shape of the graph where the discontinuity is occurring. Okay. So here I have shown some figures where the function fx is continuous. Okay, where the function fx is continuous. You see, this is a function. This is the graph of the function. This is the graph of the function fx, and the interval is x equal to A up to x equal to B. So these are the two boundaries. Closed interval is A to B, and here this is the left boundary x equal to A, this is the right boundary x equal to B. So in this graph you see at this point and at this point there are relative maximum, and at this point and at this point there are relative minimum. Relative means here you have to consider a very small interval around this point. This point is x4. Similarly, here you have to consider a very small interval around the point x3. Here around the point x1, small interval. Here the point x2, around x2, a small interval. So there is a maximum, relative maximum of the function here. There is a relative minimum of the function here. There is a relative maximum of the function here, and there is a relative minimum of the function here. Now, you see this figure shows that at this point the function has the maximum value. And at this point, the function has the minimum value, because the function value is minimum here. You see, the function value is minimum here, and the function value is maximum here. So at these 2 points, the function has absolute value, absolute maximum, and absolute minimum. So that means at the left boundary, left boundary at x equal to A, the function has an absolute minimum, and at the right boundary x equal to B, the function has an absolute maximum. Okay, let us take another figure. Look into this figure, this graph. This is again the graph of the function y equal to fx. At this point, relative maximum, at this point, relative minimum, at this point, absolute. Okay, actually, this point will give you relative maximum as well as absolute maximum. Here, relative minimum. Now, let us look into this graph. Please tell me where the absolute minimum is occurring and where the absolute maximum is occurring. Please tell me.
is at x equals to 0, relative minimum.
No, not x equal to 0, it is x equal to a.
So
At
one,
x equal to a, there is absolute minimum, because here the function value is minimum. At this, at the left boundary, at x equal to a, the function value is minimum. But at the right boundary, at x equal to b, the function value is here. This is less than the function value here. Am I right?
Miss, I didn't get the absolute maximum.
Absolute minimum means you have to look into the value where the function value is the smallest, is the minimum, the smallest.
Miss, absolute maximum.
Huh?
Maximum.
Maximum. Yes, absolute maximum means where the function value, at what point the function value is the largest. Tell me where the function value is the largest in this figure. At what point?
Miss, x equal to 3,
X equal
x2 যেটা ওই জায়গায়
to
লাগবে।
x
x3.
is equals to
At
2.
x equal to x3. This is the positive side, and here it is the largest of the function values. Of all the function values, this is the largest, because here it is the highest point. Highest point means here the function value is the maximum, it is the largest. At this right boundary, at the right boundary x equal to b, this is the function value, but here the function value is less. This function value is smaller than the function value here. You see, this ordinate gives you the function value. And here in this side, it is the minimum. The negative one cannot be, okay. If there is a function in which all the function values are minimum, then you have to find the highest of the function values. You see, this point is the highest. In the whole graph, this point is the highest point. So at this point, the function value is the largest. That's why at this point, the function value will be maximum. And this point will give you the absolute maximum value. And at this point also, we have a relative maximum also. At this point, we have a relative maximum. And at this point, this is also the absolute maximum.
Miss, why is this relative maximum as well?
As well, because if you consider a small interval here, if you consider a very small interval here, at this point, the function will have a relative maximum. If you consider
So, Miss,
a small,
does that mean
if you
that
consider the interval, listen to me. If you consider the interval a to b, then at this point you will have the absolute maximum. Then we will not say about the relative maximum. Because your interval is now a up to b. Okay.
Oh, okay, Miss. So in
But
that
Miss,
sense, means if we consider, let's say, a point before x is equals to a, then from there
Yes, if
to
you
0,
consider,
let's
yes,
say,
if you
then in
consider
that
it,
case, absolute minimum point at x is equals to a is also a relative minimum.
okay, here this point is not a critical point. This point is not a critical point, so this point cannot be a relative minimum. At this point, there cannot be any relative minimum, because this is not a critical point. Go back to the theory. You have to find the critical point in this open interval. That means
Yes,
x
because I was
cannot
talking
be
about
equal
x is equals to a, Miss.
Yes, here x cannot be equal to a, here x cannot be equal to b. You have to look for the critical points in this open interval. That means
Oh,
that
Miss, Miss, I was actually talking about, like, if we consider something before a,
no,
so
no,
a is included within. So in
no,
that
no,
case,
because your interval is the closed interval from a up to b. So you cannot consider a point which is below this a. You have to start from a. And when you find the critical points, you have to consider the open interval. That means here x cannot be equal to a, x cannot be equal to b. So that's why in this figure, x cannot be equal to a, x cannot be equal to b for the critical points. Here also x cannot be equal to a, x cannot be equal to b when you discuss the critical points.
okay, Miss.
Do you have any more question? So in this graph of the function, you see at the left hand point the function has an absolute minimum, and at the right hand point the function do not have a absolute maximum. The absolute maximum is occurring here at a critical point. The absolute maximum is occurring at a critical point. This point is a critical point because at this point the derivative will be what? 0, because the slope of the derivative will be 0 here, because here the tangent is parallel to the x-axis. The angle is 0, that's why the slope will be 0. So this point is a critical point. Here the absolute minimum is occurring at the left hand point, and the absolute maximum is occurring at a critical point. Okay, let us, there is one more figure here. Look into this figure. This is the graph of the function y equal to fx. You see which point has the lowest value here.
Miss absolute minimum, as you tell.
Yes, I didn't give the point here. Suppose this point is x1, this point is x2, and this point is x3. So you see, if this is x1, at this point the function has the smallest value. So at this critical point, if it is x1, at this critical point the function will have the absolute minimum. And where is the absolute maximum occurring?
X equal
Miss
B.
x equals to b.
X equal to B,
Absolute
right.
maximum.
Yes, at x equal to b, you are getting the largest value of the function. At this point,
Miss,
the function has the largest value. So at the right end point, the function has the absolute maximum value.
Miss, just as someone was saying about the discontinuity of a function, Miss, let's say at x is equals to 2, there is a
Suppose there is a
discontinuity.
discontinuity. Okay, I didn't draw any graph for this discontinuous function. Suppose there is a discontinuity here. Suppose this graph goes here in this way, and this graph, there is no continuous point. It is again starting here. Suppose this graph ends here in the left side, and the right side the graph starts here, and there is no connection in between these two. So there will be no absolute minimum. There will be no absolute minimum in this figure. And in the previous figure, you see the absolute maximum is occurring here. Absolute minimum is clear because it is occurring at the left hand point. And for the absolute minimum, suppose when the graph is coming from the left side, suppose it goes like this, goes upward. And in the right side, after this point, the graph is coming like this. And these two graphs you cannot join these two graphs. If you cannot join these two graphs from the left side and from the right side, then that means there is a discontinuity at the function at the point x equal to x2. So in that case, there cannot be any absolute maximum. There will be only an absolute minimum. There cannot be any absolute maximum. So you see, it depends on the shape of the graph. So if there is a discontinuity in the graph, there may not be any absolute maximum or absolute minimum. It depends on the shape of the graph. In this case, if there is a discontinuity here at this point, there cannot be any absolute maximum, because in the left side, the graph will be going like this to the upwards, or it ends here, and in the right side, it is coming from the upwards, it goes to infinity. If there is no connection in between the left side and the right side, that means there is a discontinuity at the point x equal to x2. In that case, their function cannot have any absolute maximum.
So Miss, it's not like even if it's the maximum point of that graph within that interval, and it has a concavity upwards,
If there
it
is
doesn't
any
really matter.
discontinuity, there may not be. I'm telling you, suppose the discontinuity is here. Suppose the discontinuity of the function is here. In that case, you are getting an absolute maximum, but you will not get any absolute minimum. Because if this graph goes to negative infinity here, in that case, you are not finding any absolute minimum. I'm repeating it. If there is any discontinuity in the graph, there may not be any absolute minimum, or there may not be any absolute maximum. It depends on the shape of the graph. Okay, let us now do some math on this absolute maximum and minimum. Just a minute. The maths on this absolute maximum and minimum are easier. Find the absolute maximum and absolute minimum of fx on the given closed interval and state where these values occur. So this is your function and the interval is given to you, -3 up to 2. Okay, -3 up to 2. So what was your stepping? Your stepping was, at first you have to find the critical values, critical points of this function. So for critical points, you have to find the derivative of this function. It will be 6x squared plus 6x minus 12. Take 6 common, it is x squared plus x minus 2. And for critical points, you know, either f prime x equal to 0 or f prime x does not exist. Here, f prime x exists everywhere for all real values of x lying in this interval. So we have only one condition, f prime x equal to 0. So x square minus x, x square plus x minus 2 should be equal to 0. And if you find the factors, it will be x plus 2 into x minus 2. So for critical points, you are getting x equal to minus 2, x equal to 1. So these 2 points are the critical points, and you see these 2 points are lying in this interval. Minus 2 is greater than minus 3, 1 is less than 2. So these 2 are the critical points. Now you have to find the value of this function at the 2 endpoints and at these critical points. So let us find it. Minus 3 and 2 are the endpoints, and minus 2 and 1 are the critical points. So you see, you just put down x equal to minus 3 in your original function. This was your original function. 2x cubed plus 3x squared minus 12x. Here you just put down the values of the points x. At first x equal to minus 3, it gives you 9. Then you put x equal to minus 2 for the critical point, the value is 20. Then you put x equal to 1 for the second critical point, the value is minus 7. And then you put x equal to 2, where 2 is the right end of the interval, and you are getting 4. So please look into these values. Which one is the smallest?
-7.
-7. So -7 is the absolute minimum of this function, and this -7, this absolute minimum is occurring at the critical point x equal to 1. You see, -7 is the minimum. So the function fx has an absolute minimum at the critical point x equal to 1, and the absolute minimum value is -7. And what is the largest? Largest is here, it is 20. So this value is the absolute maximum value of the function, and it is occurring at the critical point x equal to -2. So you see, for this function, the absolute maximum and absolute minimum are not occurring at the endpoints. Absolute minimum is occurring at the critical point x equal to 1, and the absolute maximum is occurring at the critical point x equal to -2. Okay, so it depends on the function. Another function, it is x squared plus x whole to the power 2 by 3, and the interval is -2 up to 3. So you see, this function, originally this function was continuous everywhere for all values of x. And you have to find the derivative. So you just consider the whole thing as your x. So x to the power 2 by 3. That means 2 by 3 into x to the power 2 by 3. Your x is x squared plus x. So 2 by 3 minus 1, it means -1 over 3. And you have to find the derivative of this inner part again. What is the derivative of this inner part? It will be 2x plus 1. So it should be multiplied by this 2x plus 1. So ultimately it becomes, what is it in the upper side? 2 into 2x plus 1 divided by 3 into x squared plus x whole to the power 1/3. Whole to the power 1/3. So now you discuss the cases for which if x has critical points. You know, for critical points, f prime x equal to 0 or f prime x does not exist. So here, f prime x does not exist if the lower part is 0. And the lower part is 0 means x square plus x equal to 0, which gives you x into x plus 1 equal to 0. That means x equal to 0 and x equal to minus 1. You see, original function was continuous for all values of x. So this x equal to 0 and x equal to minus 1 can be a critical point of this function. And again, you have to check whether these 2 points are lying in this interval. Yes, x equal to 0 and x equal to minus 1, both the points are lying in this interval. So for this particular map, you have the critical points, 2 critical points, that x equal to 0 and x equal to minus 1. Now there is another condition remaining for critical points f prime x equal to 0. If prime x equal to 0 means the upper part is 0. So 2x plus 1 equal to 0, that means x equal to minus half. So there is another critical point, minus half. So in total, there are 3 critical points. Minus 1 and minus 0 are coming from what? F prime x does not exist, and minus half is coming from f prime x equal to 0. So in total, there are 3 critical points and all of them are lying in this interval. So now you have to find the values of the function at their 2 endpoints and at these 3 critical points. So in total, there are 5 points. We just put down x equal to minus 2, x equal to minus 1, x equal to minus half, 0 and 3 in your original function here. So for x equal to minus 2, it will be 4 minus 2 means 2, so 2 to the power 2 by 3. When x equal to minus 1, it will be 0, because 1 minus 1, 0. When x equal to minus half, 1 by 4 minus half equal to minus 1 over 4 to the power 2 by 3. So if you take the power 2 at first, it will be 1 over 16. So it becomes 1 over 16 to the power 1/3. Now x equal to 0. Yes, the function value will be 0. And when you put x equal to 3, it becomes 3 square plus 3. That means 9 plus 3, 12. If you take the whole square, 12 whole square is 144. So it is 144 whole to the power 1/3. Now, please find the minimum values. What are the minimum values of this function? Please tell me.
f of minus 1 and f of 0.
Yes, the 0, these 2 zeros are the minimum value and these 2 are equal. So these 2 equal minimum values are occurring at x equal to minus 1 and at x equal to 0. So the absolute minimum value of the function is 0, and this absolute minimum for the function is occurring at 2 points, at x equal to minus 1 and at x equal to 0, and both the points are critical points. So absolute minimum is occurring at the 2 critical points, x equal to 0 and x equal to minus 1. And this one is the largest. It is 4 to the power 1/3. It is 1 over 16, 1 to the power 1/3, and it is 1 by 44. Sorry, not 1 by 44. It is simply 144 whole to the power 1/3. So definitely this number is the largest. So this largest is occurring. That means it will be your absolute maximum, and it is occurring at x equal to 3, which is the right endpoint of the interval. So the absolute maximum is occurring at the right endpoint of the given closed interval. Now this one. Fx equal to 3x divided by root over 4x squared plus 1. Here the interval is minus 1 up to plus 1. So you know you have to find the critical points of this function in this interval, which lies in this interval. So at first you check in the lower part, it is 4x squared plus 1. This is a square and this is a plus sign. So this function is defined and continuous everywhere for all real values of x. There is no discontinuity of this function. For all values of x, the function is defined and continuous. There is no discontinuity. In the previous two functions also, there was no discontinuity. Now let us find the derivative of this function. Apply the formula, the lower part whole square. It should be in the denominator, and in the upper part, lower part into d dx of the upper part. D dx of the upper part is 3. So lower part into d dx of the upper part minus upper part into d dx of the lower part. Upper part is 3x, and what is the d dx of the lower part? It is power is half. So you consider this 4x square plus 1 as your simple x. So x to the power half means half into x to the power half minus 1. That means power will be minus half. So you can take this to the lower side. Root over 4x square plus 1, and you have to multiply it by the derivative of this function. It will be 8x, because you have considered this whole thing as your simple x, but it is not x. So you have to multiply the whole thing by the derivative of this thing. So it is 8x. So in the upper part, it is 8x divided by root over 4x square plus 1. And for the power half, there is another half here. So 8 is cancelled. There will be 4. So what you are getting? 3 into root over 4x square plus 1. And here 3x into 4, that means 4x, sorry. So it will be 12x square divided by root over 4x square plus 1. Now you take the LCM in the upper part. It is LCM is root over 4x square plus 1. So when you do the algebra, it will be 3 into this into this. So the square root goes out. So 3 into 4x square plus 1 minus 12x square. And you have to take it to the lower side. So ultimately power 1 and power half, the power will be 3 by 2. So this is simple algebra. In the upper part, now you are getting 12x square plus 3 minus 12x square. So these 12x square and minus 12x square, they two are cancelling each other. So in the upper part, you have simply 3. You have simply 3. And in the lower part, 4x square plus 1 whole to the power 3 by 2. So now check. Now check. For critical points, this derivative should be equal to 0, or this derivative should be undefined. That means it does not exist. And you see the lower part contains what? 4x square plus 1, which is a positive number, and it cannot be 0 because 4x square cannot be equal to 0. Cannot be equal to 0. It is always positive number. So there is no possibility for any x which gives you the lower part 0. So for all values of x, f prime x is defined. It exists everywhere. And check, can it be 0 anywhere for any value of x? The whole value, can it be 0? Please tell me. Please tell me, can it be 0?
হবে না তো মিস x তো নেগেটিভ হবে না, সো ভ্যালুটা তো 1 এর সাথে
This
কাটাকাটি
কোনো critical point নেই.
There will be no critical point. Why? Because f prime x cannot be equal to 0, because you know f prime x will be equal to 0 if when the upper part is 0. This will be 0 when the upper part is 0. The upper part contains only 3. There is no x here. These 3 cannot be equal to 0. So there is no point where the f prime x becomes 0. So there is no point where f prime x equal to 0. There is no point where the lower part becomes 0. So for all values of x, this function derivative is defined everywhere, and it cannot be equal to 0. So there cannot be any critical point. There cannot be any critical point. Okay, for this function, there is no critical point. So you have to find the values of the function at the two endpoints. At the two endpoints.
Is critical point না থাকলে absolute maximum minimum থাকবে?
থাকতে পারে, yes. Because you see f of minus 1, it becomes minus 3 by root over 5, and f of 1 is 3 by root 5. This will be the minimum value of the function, and this will be the maximum value of function. Because there cannot be any other maximum or minimum in this function, because there is no critical point here. There cannot be any other maximum or minimum in this function. This will be the minimum value of the function. This will be the maximum value of the function. So minimum value is occurring at x equal to -1, and the maximum value is occurring at x equal to 1.
Miss, I'm actually our আগের questionটা miss it was something similar, miss. And on extension on that, miss, let's say একটা ইন্ডাস্ট্রিয়াল অ্যাপ্লিকেশনে একটা ফাংশন মিস একটা প্যারামিটার গ্রাফ প্লট করা হচ্ছে, সেখানে মিস ফর সাম কেসে একটা জায়গায় যেখানে অ্যাবসোলুট ম্যাক্সিমাম হওয়ার কথা ওই জায়গায় জিনিসটা ডিসকন্টিনিউয়াস ফর সাম রিজন। So in that case, miss, এখন এই প্রবলেমটা অপটিমাইজ করার জন্য মিস তখন কি আমরা ম্যাক্স ভ্যালুটা ধরব?
Discussing it is totally different. It is totally different because this function is continuous everywhere. There is no discontinuity here. If there is a discontinuity, then you have to find the discontinuous point. Okay, in that case you can say where either the absolute minimum is not occurring or the absolute maximum is not occurring. In that case you can say, but for this particular function, this is continuous everywhere. This is continuous everywhere. So that's why the lowest value will be the absolute minimum and the largest value will be the absolute maximum. Have you got the point?
Yes, miss.
Have you got the point?
Yes, miss.
Okay. If there were any discontinuity here, then the case would be different. Definitely, it will be a little complicated and it will be different. Now, there are some problems in which the interval is -infinity up to +infinity. I told you that here the steppings will be a little different. Find the absolute maximum and absolute minimum values of fx on the given interval and state where those values occur. So this is your function fx equal to x square minus 6 minus 2. And the interval is -infinity and +infinity. In these cases, you have to find the limiting value of the function when x approaches towards -infinity, and separately the function value when x approaches towards +infinity. Okay, so let us find the limiting value of this function when x approaches towards -infinity. So it will be limiting value of this function x square minus 6 minus 2 when x approaches -infinity. Think about this function when x equal to -infinity. So this term will give you +infinity, infinity square, -infinity, -2. So what will be the value? Definitely it will be infinity, but will it be a negative infinity or positive infinity?
Positive.
It will be positive infinity because there is infinity square. Definitely infinity square, it is a positive number whether x is negative or positive. Infinity minus infinity whole square, it is a positive infinity, and definitely this value will be greater than these two. So the result will be ultimately a positive infinity. And check the case when x tends towards positive infinity. So here again the same thing, because for +infinity whole square it is +infinity, -infinity, -2. Infinity square will be definitely greater than these two. So again positive infinity. So what you see here, when x tends towards -infinity in the left side, when x tends towards -infinity in the left side, and when it becomes, the value becomes +infinity. So the figure will be like this. It goes up when x tends towards infinity, and it will be something like this. And when x tends towards positive infinity, again it is going upwards up to +infinity. Now please tell me, will there be any absolute maximum for this function?
Miss, can infinity be a maximum? Absolute maximum?
Sorry?
maximum হবে না।
Huh? The graph is not shown here. Just think about the graph. When x tends towards negative infinity, that means when x tends go to negative infinity in the left side, the function value is +infinity. That means the function value is going upwards towards infinity. And when x tends to +infinity, that means when x tends towards plus infinity in the right side, here also the function value becomes plus infinity. It goes upwards. It goes upwards towards infinity, and in the left side also it goes upwards because both of them are positive infinity. In the left side and in the right side, in both the sides, the function value goes up to positive infinity. So can you find any absolute maximum for this function?
No,
Is it
miss.
possible?
No, ma'am.
Oh,
No, it is
Not
not
possible.
possible. It is not possible. It is not possible because in the left side and in the right side, in both the sides, the function value goes to infinity. For this x tends towards minus infinity and for x tends to plus infinity. In both the sides, minus infinity means in the left side and plus infinity means in the right side. In both the sides, the function value becomes plus infinity. So you cannot find any absolute maximum for this function. Okay, so there
Ma'am,
may be
I'm a bit confused about one thing. যে সেকেন্ডে যখন আমি প্লাস ইনফিনিটি লিমিট ধরেছি, তো তখন আমি ইনফিনিটি স্কোয়ার করে আবার যদি মাইনাস ইনফিনিটি হয়, shouldn't that be 0 and then -2?
no. You have to think it in this way. Infinity square, whatever be the large number, if you take the square, it will be a very, very large number than these two. Definitely. So if you subtract these two from this infinity square, definitely it will be a positive infinity. You have to
Then
think it in this way. Because infinity minus something is also infinity. And here it is infinity square. So infinity square minus infinity, definitely it will be positive infinity. In these cases, you have to think it in this way. So there cannot be any absolute maximum, but there may be an absolute minimum, and this absolute minimum may occur at a critical point of this function. So for this function, you have to find the critical point. So what you have to find the derivative now? The derivative will be 2x minus 1. So you have to think two different cases, either if prime x equal to 0 or if prime x is undefined. Here if prime x is defined for all values of x. So the second condition is invalid here because if prime x is defined for all real values of x. And if prime x will be equal to 0, when this 2x minus 1 equal to 0, that means x equal to half. So this half is a critical point. Your interval was minus infinity to plus infinity, so this half should be considered. So you are getting one critical point here, which is half. So there will be a minimum. There will be an absolute minimum here. You have to check. Just find the second order derivative. The second order derivative for all values of x, it will be 2. And which is a positive number. So definitely there will be a minimum. Definitely there will be a minimum at the point x equal to half. So there
Miss,
should be
second derivative টা কেন করা হলো?
second derivative test is done just to check whether
It's
you are
not
getting a
needed,
maximum
right?
value or
Absolute.
minimum value.
Absoluteর জন্য তো it's not needed. Miss, absolute maximum minimum বের করার জন্য তো second derivative.
Absolute maximum, sorry. You see, there cannot be any absolute maximum. Okay, there cannot be any absolute maximum, but this critical point may have a relative minimum or relative maximum. So at this point, there will be you see, the function cannot have absolute maximum, but the function may have an absolute minimum. This point, actually, if you consider a local interval, at this point there will be a relative minimum, but this point will also give you the absolute minimum also, because there is no other critical point here. There is no other critical point here. So there cannot be any other minimum, there cannot be any other maximum here. The maximum may be relative maximum, but there cannot be any relative maximum, there cannot be any other relative minimum here, because this is the only critical point. So this will give you the absolute minimum value. If there is other critical points, then it is there is a possibility there may be two relative minimums, and from the two relative minimums you have to find the absolute minimum. But there is only one point. At this point, if you consider a local interval, it should be a relative minimum. And if you consider the whole interval minus infinity to plus infinity, at this point you will get the absolute minimum value. Because there is no other critical point. So there cannot be any other relative maximum or relative minimum. This is the only relative minimum, so this will be the absolute minimum. And what is the minimum value? Second order derivative is found because just to check whether there is this is a point of absolute relative maximum, because there cannot be any absolute maximum, but there may be a relative maximum here. But since the second order derivative is a positive number, the point should be a minimum. Is there any question?
No, miss.
Okay, so now find the absolute minimum value. Just put x equal to half in your original function. Put x equal to half in your original function, and the value becomes what? It is minus 9/4. So this is the absolute minimum value of the function, and it is occurring at the critical point x equal to half. Okay, now we have another function fx equal to 3 minus 4x minus 2x squared, and again the interval is minus infinity up to plus infinity. So you see, you have to find the function value, limiting value of the function when x tends towards minus infinity and when x tends towards plus infinity. So this is your function. Just consider x equal to minus infinity. What will happen? X equal to minus infinity. So this term, this will be plus, it will be infinity. This term will be infinity, and then minus 2 into infinity squared. So this term, just this term will be greater than this term, and there is a negative sign. So the result will be a negative infinity, because here in front of the infinity squared there is a minus sign, and these are infinity to the power 1. Here it is infinity squared. Similarly, when x tends to positive infinity, consider here it will be 3 minus 4 into infinity, that means 3 minus infinity, that means it is minus infinity, and again you are getting another minus infinity here. So ultimately the result will be negative infinity. So you see, in the left side the function value goes to negative infinity like this, and in the right side also the function value goes to negative infinity. I am showing it by the cursor. In the right side it will go, the function will go like this, the graph will be like this, going to negative infinity. In the left side also the graph will go to the negative infinity. So can there be any absolute minimum here?
No, miss.
No,
No,
there
miss.
cannot be any absolute minimum, but there may be absolute maximum which may occur at a critical point. So you have to find the critical point of this function. So you have to take the derivative. What will be the derivative? It will be minus 4 minus 4x. Yes, minus 4 minus 4x. You take minus 4 common, it will be 1 plus x, and when for critical points f prime x equal to 0 or f prime x undefined. Here f prime x equal to 0 when x equal to minus 1. So this is a critical point, and this will be the only critical point because f prime x exists everywhere for all values of x. So this is the only critical point. Now let us find f double prime x, because this is a critical point. There may be a relative minimum also. Okay, so what is the second order derivative? Second order derivative will be what? Minus 4. And minus 4, it is always a negative number. That means the corresponding point should be a relative maximum, and there is no other critical point, so this maximum will be actually absolute maximum of fx, because f prime x exists everywhere for all values of x, since f double prime x equal to -1, which is less than 0, it is a negative number, so the corresponding point should be what? Maximum. For all x, the function fx has an absolute maximum. This function cannot have any absolute minimum, but this function may have an absolute maximum, and we have found that this maximum is occurring at x equal to -1, and since there is no other relative maximum or minimum, this point will give you the absolute maximum. So at x equal to -1, what is the function value? It gives you 5. So this 5 is the absolute maximum value of the function.
Miss, relative maximum to পেলাম, তাই না?
If you consider a local interval, yes.
Yes,
Your
plus
total
absolute.
interval was -infinity to +infinity. But if you consider a small interval, local interval actually, around this point -1, then this point will give you a relative maximum. Okay, but here in these maths we will not mention these maximum or minimum as relative, because in the previous problems the intervals were mentioned, and in these two problems the interval is -infinity to +infinity. So we are not considering any local interval here. So we will not say about the relative things, relative maximum or relative minimum.
মিস আগের ম্যাথটাতে লেখা ছিল রিলেটিভের কথা, এইজন্য।
Okay, did I mention it?
Yes, miss.
If I have mentioned it, then it should be, I should have mentioned that for a local interval, it will be a relative maximum or minimum. So if you add the words for a local interval, then it is okay. So I should have mentioned the words local interval. Is it clear?
Yes, miss.
Okay. So let us now proceed. We have done these two. Now this math. Fx equal to x to the power 4 plus 4x. Again, the interval is -infinity up to +infinity. So here, let us find the value of this function when x tends towards -infinity. You just think about this, -infinity whole to the power 4. That means it becomes a positive number, positive infinity to the power 4 plus 4 into a negative infinity. So infinity to the power 4, this term is positive and this is negative. So it will be definitely a positive infinity. And when x tends to positive infinity, definitely it will be positive infinity. So you see in the left side, the function value goes upwards towards infinity in the left side. And the right side also, the function value goes towards positive infinity. So for this function, there cannot be any absolute maximum. There cannot be any absolute maximum. So this function may have absolute minimum, which will occur at a critical point. So let us find the critical point. For finding the critical point, you have to find the derivative. F prime x equal to 0, it gives you x cube, 4x cube plus 4. Yes, 4x cube plus 4. So you take 4 common, it will be x cube plus 1. Now apply the formula a cube plus b cube. It will be x plus 1 into x square minus x plus 1 equal to 0. Now this function, this derivative, it is a polynomial function. So this derivative exists everywhere for all values of x. So there remains only one condition, f prime x equal to 0. So for f prime x equal to 0, these two factors, products of these two factors will be equal to 0. So either x plus 1 equal to 0 or x square minus x plus 1 equal to 0. So when x plus 1 equal to 0, you are getting what? X equal to -1. And when x square minus x plus 1 equal to 0, you are not getting any real point, because if you solve this equation, there will be no real roots. Both the roots will be complex. So for critical points, you are not looking through imaginary or complex points. You have to look only for the real points. Okay. So there is only one critical point, which is x equal to minus 1. So now let us find the second order derivative. It will be 12x square. Yes, 12x square, and for any value of x, especially for x equal to minus 1, it is a positive number. So the corresponding point will be a absolute minimum point, because this function did not have any absolute maximum, and the second order derivative is a positive number, so there is occurring a minimum here, and this minimum point will be the absolute minimum point for this function. And the minimum value is this. Just put down x equal to minus 1. X equal to minus 1, so it will be 1 plus 4, that means 5. So if x equal to 5, I'm sorry, x equal to minus 1, then sorry, x equal to minus 1, so it will be minus 4, so 1 minus 4 equal to minus 3. So this value, minus 3, it is the absolute minimum value of the function, and this absolute minimum is occurring at the critical point x equal to minus 1, and there is no absolute maximum for this function. We have 2 more pages here. Now the function is 4x cubed minus 3x to the power 4. The interval is minus infinity up to plus infinity. So when you take the limiting value, when x tends to minus infinity, you see this power is 3 and this power is 4. Definitely this is greater. This term is greater than this term. So the result will be minus infinity. And again, when x tends towards positive infinity, again, this is power 3, this is power 4, and this term will be greater than this term. When it was minus infinity to the power 4, it is a positive number. So this minus sign remains. So ultimately the result is minus infinity. Here also you are getting minus infinity. So for this function, there cannot be any absolute minimum. There cannot be any absolute minimum. So there may be an absolute maximum which may occur at the critical point. So let us find the derivative. The derivative will be 12x square minus 12x cube. So let us take 12x square common. It will be 1 minus x. So the critical points will be, there will be 2 critical points, x equal to 0 and x equal to 1. Because when x equal to 0 and x equal to 1, f prime x becomes 0. And if prime x is existing, or it is defined everywhere for all values of x, so you are getting the critical points only for one condition, f prime x equal to 0. And these are the 2 critical points. So let us now find the second order derivative. What will be the second order derivative? It will be 24x minus 36x squared. And let us put down x equal to 0 in this second order derivative. This is 0, so no confusion here. And here, if double prime 1, it is a negative number. So there is a maximum here. There is a maximum here. Now, there is a maximum here. So I didn't find, I didn't use the first derivative test, because if you check the function value for this x equal to 0 and for this x equal to 1, this is a criteria. Yes, you just go back to the original function and put down x equal to 0 and x equal to 1. The maximum value will be give you the absolute maximum. Put here x equal to 0. So the function value is 0. And when you put x equal to what? X equal to 1, x equal to 1, it will be 1. So which one is greater? F of 1 is greater than f of 0. So definitely at x equal to 1, the function will have a maximum. It will be an absolute maximum. So here I have mentioned which shows fx has a relative maximum in a local interval. Considering a local interval, you could please include the words in a local interval at x equal to 1 and x equal to 0. And at x equal to 0, fx may or may not have an extremum. Okay, since f of 0 equal to 0 and f of 1 equal to 1, so in between these two values, which one is bigger? This one is the larger one. So f1 is greater than f of 0. So the function fx has an absolute maximum at x equal to 1. Here, the relative maximum, when you are considering a local interval, it gives you actually the absolute maximum for the function in the interval minus infinity up to plus infinity. Okay. You see, for this function, the interval was minus infinity to plus infinity. So when you are taking x tends towards minus infinity, yes, minus infinity whole cube, it will be minus infinity to the power 3. It will be plus infinity. So the result will be a minus infinity. And when x approaches towards plus infinity, it will be positive. Infinity to the power 3 and then minus infinity, so it will be positive. So you see, in the left side, in the function value is always going towards minus infinity. And in the right side, when x tends towards positive infinity, the function value goes towards positive infinity. So in the left side, the graph goes downwards towards negative infinity. Right side, the graph of the function goes towards positive infinity. So can there be any absolute extremum? There cannot be any absolute maximum, there cannot be any absolute minimum, because in both the sides, in the left side and in the right side, the function values are going towards negative infinity and in the right side towards positive infinity. So for this function, there is no absolute maximum and no absolute minimum. Here also it is the same thing. When x tends towards minus infinity, the function value becomes minus infinity, and when x tends towards positive infinity, the function value becomes positive infinity. So in both the sides, here in the left side, the function value goes towards negative infinity, and in the right side, the function value goes towards positive infinity. So in this function also, for absolute minimum. I think this was the last math here, and for practice, I have done a lot of problem from this exercise. Still, there may remain some maths, so you please try it by yourself. And also, this is your home. This is your task. Actually, you have to do all yourself. It is exercise 4.4, and you have to try with these maths. Question number 7 up to 16, and then question number 21 up to 26 for this absolute maximum and minimum.
Miss 4.5 থেকে
Sorry?
Miss 4.5
Sorry?
4.5
4.4. The exercise is 4.4.
Miss this is 4.4 4.5 থেকে করব না বই 4.5 Yes miss
Let me see. Let me check. Just a minute. Just a minute. Absolute maxima and minima, it is exercise 4.4.
Yes miss and application টা 4.5 না
Means it was, I think it was 4.3. 4.3 was application of maxima and minima. I mentioned the exercise in our last class.
Miss course outline এ 4.5 লেখা
4.5. So that
Yes,
means it will be 4.5.